Okay, everybody, we are looking at question 10 in your chapter 8 practice test. We got find the length of the curve y equals integral from 0 to x root cosine 2t dt as x goes from 0 to pi over 4. So this is a little bit different than the one that we just did because this time we can't really see what the curve looks like. Your TI calculator doesn't really graph that very well. There is a way to graph it, but it's not really something that I recommend you spend time doing. So instead, we're going to take a look at the formula here that's relevant. Sorry for all the background noise. So the formula, we wrote it in the previous problem. The formula that you're going to be doing is that the arc length is equal to the integral from a to b of the root of 1 plus dy dx squared dx. Okay, so all we really need to make this work is we need dy dx. Luckily we have an equation here for y. So let's get our dy dx. So dy dx is going to be equal to the derivative with respect to x of 0 to x root cosine 2t dt. Okay. And you'll remember from our fundamental theorem of calculus, we've got the derivative of an integral. We've got x over here, that matches with the x over here. This is constant right here. So all we need for the derivative is to substitute our upper limit into our integrand, and we've really done it. So dy dx is equal to root cosine 2t. Okay, and I think as opposed to what I did last time, I don't think I'm going to take a whole lot of chances here. We'll just make our arc length equal to. Tells us nicely that we're going from 0 to pi over 4. Root 1 plus, again, like I said, this is another strategy which you might want to adopt. Considering that we have a calculator at our disposal, I won't simplify the derivative too much. Really not at all. I can see I also made a mistake. These should be x's. Two x, then dx. Okay, and let's just chuck that into our calculator. We got the integral. That is over 4. We're going from 0 pi over 4 radical 1 plus, we got a quantity here that is the square root of cosine x, cosine 2x. Can't seem to be getting this stuff right. Cosine 2x. And you're squaring that derivative. With respect to x. Let's take and make sure that looks like what we want. Quantity of root cos 2x squared. Quantity of root cos 2x squared. Okay, so that looks good. We'll hit enter, and our calculator gives us 1, which Yeah, that looks correct. Equals 1. That's our problem for question 10.